Come to this lesson. So in this lesson, we want to look at scalar products of vectors. So at the end of this lesson, you should be able to find the scalar products of vectors. You should be able to find the angle between two vectors. So let's dive into the lesson. When we say scalar product is different from scalar multiplication. In scalar multiplication, we use a number to multiply vectors. Or a number that is just a scalar or a magnitude that does not have direction ijk. So when you use a scalar to multiply a vector, the result is called scalar multiplication, and the answer is always a vector. But in scalar product, we try to multiply two vectors together, and the answer is always a scalar. So the result of this multiplication that we have here, the result is a scalar. Is a scalar, okay? So scalar product does not mean direct multiplication of vector. So we cannot multiply vectors directly, just like we multiply number, like 2 times. We cannot say 2i times 2i equals to 4i. No, because this will be, we can't even say I times I. There's nothing like I times I equals to I squared, okay? So we basically don't have direct multiplication of vectors. So what we have is scalar product and cross product. So scalar product is just a strategic multiplication of the component of the vector, and the result is always a scalar. While vector product, also called the cross product, you have to use matrix to multiply the vector. Okay, so here, the scalar product, sometimes called the dot product of two vectors a and b, is written as a dot b and is equal to magnitude of a cross magnitude of b times cos theta, where cos theta is the angle between a and b. So by definition, the dot product is given by this formula. Okay, scalar product is also called dot product. Okay, so it is also known as dot product. Let me write it down. So when we say scalar product and dot product, we mean the same thing, okay? Because instead of putting a multiplication sign, the sign that is always used is dot, a dot b. Because if we put a cross b, a times b, so that times is called cross, and it has another meaning in vector, and it is called vector cross product. So for scalar product, we use the dot, okay, the dot, okay. So A dot B is given as magnitude of A times magnitude of B multiplied by cos theta, where theta is the angle between the two vectors A and B. So the scalar product is given as A dot B equals to magnitude of A times magnitude of B cos theta. And this is how to prove the result, okay? So there are simpler way to calculate the scalar product. So the vector triangle show that C equals to B minus A, and suppose that two vectors A and B can be written in column form as A equals to A1, A2, A3, B equals to B1, B2, B3. So the scalar product here, A dot B, will be equal to A1, B1 plus A2, B2 plus A3, B3. Okay. The reason why it is like this is that if you do I dot I, the answer is equals to 1, J dot J, the answer is equals to 1, and K dot K, the answer is equals to 1. Okay, so just like we have I square, K square, they are all equals to 1. So when you multiply, when you are doing dot product, you multiply the corresponding component of the vector, multiply the corresponding component and add the answer together. Then we have what we know as what is called the dot product or the scalar product. Okay, so this is the simpler way of doing a dot product, and this is the proof, guys. So if C is B minus A, which is B1 minus A1, B2 minus A2, B3 minus A3, then if we take the magnitude, if we take the square of both sides, we have this, and then if upon expansion we have this term. If we collect like terms, we have some terms will cancel each other, and then bringing the terms together, we have a1 square, a2 square, a3 square, which is magnitude of a square, plus magnitude of b square minus 2a1b1 plus a2b2 plus a3b3. So this looks like cosine rule, right? So, and then we came about a magnitude of c. If you take the square root of both sides, we have magnitude of c equal to or that. So c square is magnitude of a square plus b square minus 2ab cos theta. Okay, so this is actually the cosine rule. So comparing the both sides of the equation, we have a dot b is magnitude of a magnitude of b cos theta, which is a1 b1, a2 b2, a3 b3. So a dot b is a1 b1 uh, plus a2 b2 plus a3 b3. Okay, where a is a1, a2, a3, and b1 is b equals to b1, b2, b3. So this is the formula for computing the dot product. Just multiply the corresponding component. So let's see an example and then see what we can do here. So before we do that, let's see an example. So e.g., if we have a equal to 2, 4, 6, um, and b, okay, so b equal to minus 4, 5, 7. So let's call it small letter b. So a dot b will be equal to, so we just multiply the corresponding component. 2 times minus 4 plus 4 times 5 plus 6 times 7. Multiply corresponding component, and that will be minus 8 plus 20 plus 6 times 7, which is 42, and that will be 62 minus 8, and that is 54. Okay, so this is what we have. So 54. So this is how to do those products. So we can also calculate angle between two vectors. Remember that we said that a dot b equals to magnitude of a magnitude of b cos theta, which is equals to a1 b1 plus a2 b2 plus a3 b3. So we have that cos theta equals to a1 b1 plus a2 b2 plus a3 b3 all over that. So we just multiply, manipulate the formula we already have for dot product, and then we make cos theta the subject, and then we have the magnitude. So magnitude of cos theta is always equal to a dot b all over magnitude of a times magnitude of b. So that is angle between two vectors. Theta is the angle between two vectors, and then we have that if theta can be equal to 0, if theta is equal to 0, that means the vectors are parallel, and if theta is 90 degrees, that means the vectors are perpendicular. Okay. So special cases, A1, B1, if the dot product is equal to 0, then theta is 90 degrees. So that means the vectors are perpendicular to each other. Okay. And then if A dot B equals to 0, okay, then the vectors are perpendicular to each other. And then the other case is parallel, when if uh, if we have this one, let's analyze that here also. So if we have that A1, B1 plus A2B2, okay, plus A3B3 equals to 1, or let's say, yeah, 1. So what do we have? That will be cos theta equals to 1. So theta equals to cos inverse of 1, which is equals to 0 or 360 degrees. Okay. Basically, we use the acute angle, so theta equals to 0. So this gives that the vectors are parallel to each other. Okay. So those are the special cases. Example: find the angle between the following pairs of vectors. So you know how to find. We are going to follow the steps, and then you see how it happens. So we have a I plus j plus k. Let's say this is vector A. Vector B is I plus 3j plus 2k. Okay, so to find the angle, we follow step by step. Step 1, okay, Step 1, find the dot product. A dot B is A1 B1 plus A2 B2 plus A3 B3, okay, which is going to be 1 times 1 plus 1 times 3 plus, just multiply the component, ignore the direction, 1 times 2, okay, so 1 plus 3 plus 2, which is 6, okay. And then step 2, we compute the magnitude, okay. So the magnitude is going to give us something like this. Magnitude of A will be equals to square root of 1 squared plus 1 squared plus 1 squared, which is square root of 3. Magnitude of B, that will be square root of 1 squared plus 3 squared plus 2 squared, which is magnitude of 1 plus 9 plus 4, which is magnitude of 14. Okay. So therefore, what's the next step now? We have the magnitude. So this step 3 will compute the theta. We use our formula. Cos theta equals to A dot B all over magnitude of A, magnitude of B. So what's A dot B? That's 6. 6 over root 3 times root 4. So we have cos theta equals to 6 divided by root 3 multiplied by root 14. Okay, so and then we need a calculator at this point. Get your calculator and let's work along. Alright guys, so 3 times 14, that is 42. So this is 6 all over square root of 42. So if we do 6 divided by root 42, we're going to have cos theta equals to 4 decimal places, 9258. So theta equals to cos inverse of 0.9258. Okay, so taking the cos inverse of that, we have 22.21 degree. So that's the angle between the vectors. So this is how to compute angle between the two vectors in 3 steps. Okay. So